Hello, this is the second video for section 2.5, honors geometry. The first one we talked about a couple of the properties of equality, addition, subtraction, multiplication, division. Distributive property was in there, but we just use it to solve algebraic equations. So, these properties here, you don't need to copy down all of this, but there are certain things that you do need. This reflexive property of equality. Basically, what it says is something equals itself. It's a very weird thing to say, but when we get going with geometric proofs, you're going to use this a lot. It's one of those just kind of formalities, but you're going to use it a lot. So copy this down. You don't really need the real numbers part, but you definitely need this one, these two, sorry. And so like it says, reflexive property just means a segment is equal to itself or congruent to itself. In order to make that statement and know it's true, it's a reflexive property equality. Works the same way with angles. Again, it's kind of a weird thing, but we're going to use it a lot, so please copy it down. The next one we really don't use a lot. So you don't need to copy it down, but you do need to pay attention to it and understand what it is. The symmetric property of equality, okay? And it is a property of equality. Basically what it says is, if you have segment AB congruent to segment, or equal to segment CD, if you just switch the order, it's still equal. Even weirder than reflexive. We don't use this barely ever. But it is a property. Please know it, because you may see it on a quiz or in a test or in the homework. So when they say symmetric property of equality, you got to know what they're referring to. But basically it's just, if two things are equal, A equals B, then you can switch that order and they're still equal. Okay, the next one, this bottom one here, transitive property of equality. Big time, you want this one. Copy this down, transitive property of equality. Again, you don't really need it for the real numbers so much, but definitely for the segments and the angles. All right, the transitive property of equality is kind of like a substitution. And so I'm looking at the segment length one, and I'll just copy it on the other side. If we have segment AB congruent to segment CD, and then we also know that segment CD is congruent to segment FG, some other segment, well, if AB is congruent to CD, and CD is also congruent to FG, that means these two segments have to be equal. So we could say that segment AB is congruent to segment FG. This is the idea of the transitive property. You've got two sets of things equal, but there is a connection in there. AB is congruent to segment CD. Well, CD is congruent to segment FG. We can then make this statement. It's very much like that chain rule that we talked about with the logical arguments. If AB is congruent to CD, and if CD is congruent to FG, then AB has got to be congruent to FG. And the same thing works with angle measurements. This is a property, we're going to use it all the time. Please know it frontwards and backwards. So let's try a problem with this stuff. Okay, so you're given this picture. You were told that the measure of angle ABD is equal to the measure of angle CBE. So when you're dealing with these pictures, sometimes it's helpful to just put some information in the picture. Measure of angle ABD, that's this one, is equal to the measure of angle CBE. That's that one. So that's what you're told. That's the given information. The question wants you to show that angle 1 and angle 3 are equal to each other. And so looking at the picture with the blue and the red there, you can see the blue is made up of angles 1 and 2. The red angle is made up of angle 2 and 3. So you've got this angle, angle 2, that's in common with both of them. Right? And that's a key idea here. So, to show that angle 1 equals the measure of angle 3, what we're going to do is start with the given information. Basically, that's the only thing you know, so you got to start with it. Measure of angle ABD equals measure of angle CBE. Okay, so we got two things that are equal. Now, again, angle 2 is the same angle in both of them. So what I'm going to do is make this new statement. Measure of angle ABD minus the measure of angle 2 equals measure of angle CBE minus, forgot the M, minus the measure of angle 2. Now, when you're making these statements, you've got to be able to justify them. Why is this a true statement? Well, up here, we know this is true because it's what the problem told us. It was given information. This second statement that we just made, what we did was we took our given information and we subtracted the same thing from both sides. That's the subtraction property of equality. Okay. We just subtracted the same number from both sides. It stays equal. So now, what we need to do is make another statement. We know, looking at the blue angle in the picture, the measure of angle ABD is equal to measure of angle 1 plus measure of angle 2. Okay, the reason that's true, this is the angle addition postulate. Angle addition postulate. We can make a similar statement dealing with the measure of angle CBE. If you look back at the picture, angle CBE is the red one. That's made up of angle 2 plus the measure of angle 3. All right. And same reasoning here. The reason we can make that statement again is the angle addition postulate. Okay. Let's kind of recap. We were given this information. We're trying to show angle 1 is equal to angle 3. So, we took the given information, angle ABD equals angle CBE. And then we subtracted angle 2 from both of those. We're trying to get to a statement where it says angle 1 equals angle 3. So, right here and right here, we're going to make a substitution. I'm going to take out this measure of angle ABD and plug in what it's equal to. That's the substitution property. So what we're going to have is this new statement. Measure of angle 1 plus measure of angle 2. That's where the measure of angle ABD was in this statement. Then we got this minus measure of angle 2 equals. I'm going to do the same thing for angle CBE. I'm taking it out and replacing it with what it's equal to. So measure of angle 2 plus measure of angle 3 minus measure of angle 2. The reason I can make that statement, all we did was substitution. Substitution. I always misspell that word. Substitution. Okay, so this is why the new statement is there. We took this out and replaced it with what it's equal to. We took this out and replaced it with what it's equal to. Now, if you look at your equation, angle 2 minus angle 2 plus the measure of angle 1 is just the measure of angle 1 equals. We got this angle 2 minus measure of angle 2. Those things cancel each other out. There's our measure of angle 3. Measure of angle 1 equals measure of angle 3. That's what we were trying to get to. This is a big problem. Okay, this is a geometric proof. It's something that we're going to build into, but what we're really concentrating on is this stuff. We're making some statements in all these equations, but we're justifying our statements with these properties of equality. That's the key thing. All right. That's it. Have a good night. See you tomorrow.